Okay, my friend, hello. My talk tonight, of course, tonight would be the time in Tehran. I'm just staying in Tehran right away, but my friends are in Canada, in Toronto, and probably some people in Edmonton. However, the talk that I've chosen for this session is the application of soft and hard data fusion in Industry 4. So why I have chosen this, as a matter of fact, the importance of the concept of Industry 4 is very highlighted in the industry as well as in the educational actually environment. Industry 4, I will just explain a bit on concepts that already started in 2013 in Germany. And now the interaction between human and also machine has caused the concept of fusion of the soft and hard data. So the contents of my talk would be just a brief history regarding of the Industry 4, and then we go through the Industry 4 principles. And there are good conceptions here, horizontal integration as well as vertical integration. I will talk about this. That would be a very intelligent, actually, matrix that we have to choose where we are in this matrix, by the way. Concept of digital transformation, you may be aware of it. We go through the 5 principles of the digital transformation. Then I will talk about the data fusion principles and practice. So I will go through the definition principles and some models, the levels, I will talk about that. And then basically we will go through the soft and hard data fusion. And I just classified the three parts: principles, applications, and some typical research work in literature. At the end, we will finish and conclude with the conclusion. As you see here, we see that probably all countries now are located in the Industry 3 phase. And if you go back to 1784, we have started, all the human beings started actually to have such this revolution, they call it, industrial revolution, generation 1, they call it. So it was simple mechanisms regarding of the steam power, or perhaps weaving, loom. And then it has switched to the mass production in 1870, assembly line and electrical energy. And nowadays we are involved with the Industry 3 revolution, which is just regarding of the automation, computers, and electronics issues. However, from 2013, we have a concept of Industry 4, which has some new concepts also: CPS, cyber physical systems, IoT, Internet of Things, and networks, all this stuff. So if I go back again and see these revolutions, again, you would see the first revolution was just mechanism and steam power. The second one was regarding of the mass product. And third one brought to automation, computing, and robotics. But this one, Industry 4, has many names, by the way. It may be called a smart factory. It may be called cloud-based manufacturing, factory of the future, smart manufacturing, and digital manufacturers. All are the synonyms for this next big revolution, by the way. If you see here, you would see that I just take this down here, okay. If you would see here, it is involved in the Industry 4 elements, that basically it has 3 elements. It's based on the IoT, or some people call IIoT, Industrial Internet of Things, and then a smart factory, and the cloud computing. However, the other issues that you would see in the literature, they have highlighted using of the smart sensor, advanced robotics, big data analytics, 3D printing, augmented and virtual reality, as I mentioned, cloud computing and location detection. These are the involvement of the Industry 4 elements. So now you would see that it's some sort of revolution in the information, how we share the information, how we can interpret the information, how we can use the information, all are in the directions of the Industry 4 so far. Industry 4, as I mentioned, is information intensive transformation. It's some sort of revolution in the information. Now we will see how this information are caused and how we can actually integrate or fuse this data. So as I mentioned, that three basic IoT, cloud computing, and a smart factory, it has been engaged with some issue in the cloud computing, such as edge intelligence, or sometimes they call the fog clouding, all this stuff, involving with the machine intelligence and artificial intelligence issue. These are the issues that are concerned in the Industry 4. The edge computing, just briefly, I mentioned that the power consumption is an important issue. So how we can actually use the cloud computing, but try to arrange the power supply for the network, for our networks, very quite close to the location of the data processing. So that's called edge computing in somehow, and in some literature, there are some middle stage between edge and cloud, they called fog computing. These are the issues that most of the computing engineering experts could talk about. I was very impressed by this slide from this company, Spectra Lenses. They have mentioned about all the issues of the Industry 4. Predictive maintenance is an important issue. In our power plants, unfortunately, the operators or the agent who is actually responsible for running the power plant, they don't want to get to actually expose the data because sometimes you might find actually some of the problems in the running of the systems. But with the Industry 4, we have the predictive maintenance. It means if there would be some fault, and if we cannot detect that, probably after 3 or 6 months, that actually power plant, or perhaps that industry will be shut down. So before that, this critical happens, we may actually analyze the data. So that was the predictive maintenance is an important issue in the Industry 4. So in Industry 4, we will see other issues: big data, smart sensors, sensor fusion. That was I was impressed that the other group in the industry was very interested in, rather than the academic environment, which near 25 years I'm involved with the sensor and data fusion. But I'm very happy that in the concept of Industry 4, it has been used and it has been addressed by this company. IoT, cloud computing, advanced algorithm, artificial intelligence, and automation. This is a good, actually, some sort of prospect and view of the using of the Industry 4. Again, if I just emphasize on the cyber physical systems, that nowadays, most of the systems for monitoring, for remote diagnosis, for track and traces, we have to have some sort of the agent or capability of protecting and guarding and filtering of the elements which are used in the Industry 4. So CPS is an important issue. Establishing of that and how to deal with and how to actually defend from our systems. Unfortunately, there are plenty of reports in North America, in Europe, even in Asia, I mean in Iran, in some places, that there was some reports that some attacks actually occurred in the some big industrial test beds or industrial plants. So CPS is an important issue which I can emphasize that is the basic of Industry 4. And with this, we can have a very good capabilities of actually keeping our data, running the data without actually fearing of any attack or issues. Still there are plenty of research and working on the developing of the IDS or intrusion detection system, which is a part of the CPS. Still, we have to carry on this concept. So CPS in the context, I told you, but it still is going, as I mentioned, as an evolution from the mechanical systems or mechatronics or adaptation or as a general cyber physical system. We are on the stage of the evolution because of the facing with a complex system. From now on, we have to consider all this stuff. However, as I mentioned, two important issues are considered in the Industry 4. The concept of integration. Integration in somewhat means some sort of combination, but however, it has been divided into horizontal and vertical one. What we mean with the horizontal integration, it comes out from the concepts called digital transformation in the digital manufacturing. When they call horizontal integration means how we can have some sort of sequential actions from supply to the products and to the distributor and to the end user. So the concept of supply chain management in the industry has been concentrated on the horizontal integration. So in the horizontal integration, we have to see what sort of logistics, what sort of the control actions, what sort of actually distribution methods. At the end of the story, we have to have the customer relation management, CRM, in this horizontal. But what we call vertical integration is just focus on the automation pyramid. It comes from the physical layer, which involves with the sensors and the actuators, goes up to the local control unit, goes up to the PLC, goes up to the SCADA, and then to the ERP, enterprise resource planning. These are the issues that are highlighted. So I just go briefly to this issue. As I mentioned, integration of the IT-based systems across the various production and business planning process. This is the major part of the horizontal integration. As I mentioned about the digital transformation, so it is about digital transformation across the full value and supply chain. All the data exchanges and connected information system take the center stage as this. And then there is a reference of industrial 4 protocol that called RAMI and RAMI 4. So all of the, all the issues that we have in the horizontal integration should comply this standard. This is the standard that which I just addressed later on that. However, as I mentioned, information is an important issue. So in the horizontal coordination, all the collaboration, cost-effective value savings, value creation, speed, and possibility to create horizontal ecosystems of value are all based on information. You would see here from the supply, development, product, logistics, distribution, and end user customers. These are the issues that are considered on the horizontal integration from supplier to customer. So if we would like to draw a big matrix that in the column, that this is for the row, but if in the column symbols, if we go through that, we will see the concepts of the vertical integration. As I told you, it's some sort of hierarchical system. Hierarchical systems we usually use for the automation pyramid. And this concept also, IT is one of the important issues that we have to consider there. As I told you, when we have the field level or physical level, we are involved with the sensors and actuators. And if we go up, upper levels, the second one is the control level that regulates the machines and the systems. After that, you would see that we have the process line level or actual production process level, the operation, planning, quality management, all this stuff. And that EPR or enterprise planning one that considers all the management and all the cost effective of the systems. So in the vertical, as you see, we are involved with the sensor actuators, PLC, SCADA, MES, ERP, all of the stuffs that are used in the hierarchy. So from one point, we have this vertical integration. And from the previous one, you just notice that we had the horizontal. The way that they say every people would like to consider, if they want to consider actually the implementation of the Industry 4, we have to have this metrics and see globally the system and then locally do the action. So we have to see in which level of automation and in which level of supply chain management we are located. And then we can move towards our destination or the goal of that industry. This is another picture that is used for the automation pyramid, the same as the previous one, but I just use it because most of our colleagues have the background in the control system, so it might be useful in this respect. So again, it was regarding this slide is regarding that automation pyramid, but there is a concept in the information. As I told you, all the nature of the work in the industry for is just based on the information. And you would see there is another issue called DIKW model, data, information, knowledge, and wisdom. I had an slide before, I remember in one of the conferences. On the left-hand side, it was the authors actually concepts that they have used. I used the concepts on the right one. And then I just presented it somewhere and just acknowledge regarding of the, with the courtesy of this slide I have. It is exactly the symbol of the using of the automation in a autonomous vehicle, by the way. So the sensor that starts here, the physical layer, and then data fusion is used. And then according to that, after data gathering and feature extraction, a decision-making is based on all the data, such as, say, for example, if we have the cruise control, adaptive cruise control make decision, and then using the brake, all this stuff returns back to the actuators of the system, of the car, by the way. So I just mentioned in the previous slide, we have a model called DIKW. On the right-hand side, usually for the systems are based on the cloud computing or IT, we have the information, first of all, and then we have the knowledge discovery rather than feature extraction. And we have the intelligent decision-making rather than just decision-making. So this is the model that's, of course, we will be involved with the data, but what we mean with the information is some sort of XML file. It means it's not just digit data, binary data. It might be a table, text, pictures, sound, all this stuff that's called here. So after data, it's better we consider information and then knowledge discovery from information and then going ahead for making an intelligent decision making process. Now, briefly, I go towards this. You know, most of the mechanical engineering nowadays, they have the conferences and they use the Industry 4. And it is a journey, by the way, from the conventional manufacturing towards the digital one. So this journey from traditional manufacturing to data-driven business ecosystem, as I mentioned, data and information are very important. They have also 5 principal things. They have the integration concept again. They have the concept of interoperability that it is based on the OSI or Open System Interconnects. Means we have to be open to the vendors. We have to be vendors free from point of software and hardware. This is an important issue that IEEE emphasized on that. And for the industrial control network, they have highlighted. And now we see that Industry 4 also considers that, especially on the digital transformation. So after that, as I mentioned, if we consider a multi-agent system, we have this data security and some sort of transformation skills we need. Some people may actually protest and say that if you go towards totally digital transformation, how about the labors on these concepts? So human resource management is another issue that from point of the transformation skills, we mean that we have to upgrade the skills of the experts in the systems. So this should be done in this revolution. We are telling that we are using the human being, we are using the labors, but we have to educate them. We have to educate them, by the way. We have to upgrade their knowledge. And again, we will consider what sort of technologies are involved in this journey, by the way. So I just briefly explained about that. This is now highlighting about the integration concept, about the vertical and horizontal integration. But I would like just to emphasize to this very, very beautiful concept, digital twin. If I translate the digital twin into a very professional way, digital twin is the modeling or actually transformation of the physical plant to the digital environment. It means that if you can model your plant to the digital and try to maneuver on that, and then try to use all the control or all the strategies that you want to do for the management purposes. So this digital twin is the counterpart of the physical systems. I have to mention that there was a conference that some people actually claim that we can do all this digital twin modeling perfectly, but I had a question over there, and still this question is open for our audience, and I will be very happy at the end of this talk. We just talked about details regarding of this concept that I have some sort of ambiguity on that. I mean, if the digital twin is the counterpart of the digital physical system, how about actually the human being, the operators, the technicians, the engineers, how you could actually model them? That's why that we have to use the concepts of a behavioral model. Say, for example, if an accident happened in a power plant, and if you want to analyze what was the source of that, in addition to actually checking all the instruments, controller, all this stuff, you have to consider whether the technicians were in the normal situation, were they healthy, were they actually concentrating on their work or not. So in the digital twin, there is another issue that we have to consider, is the modeling of the behavior of the human being involved in this actually process. So I will just concentrate on that later on. Perhaps a few slides at the end of my talk would concentrate on that, and then we will open a discussion with each other. Hope. Okay, and then let's go to the concept of interoperability. As I mentioned, there are plenty of the companies that they would like to play an important role in the actually dominating and governing on the industry. But it's important that we have to be very openness towards using the different networks or different hardware. That's why that plenty of the references, such as the models that we have to consider, that the RAMI4, Reference Architecture Model Industry 4, or the one called the Regional Initiatives in China, Internet Browser, or in Japan, they have a Robot Revolution initiatives that they have also standards. In United States as well. So we have to consider some sort of interoperability rather than being under the actually or the compliance of the private companies. So this is very important that we have to have some sort of interoperability across the platforms to achieve the fully autonomous systems. Skills. As I told you, nowadays, the data scientists are needed to build models to refine and learn from data. It means nowadays, the companies should not be competition to each other. They have to have collaboration. They need to work actually from anywhere, anytime, as the established industry structure will dissolve actually. It means that for this skill transformation, we need digital transformation for these purposes as a workplace. So all the scientists should share the data to each other. They shouldn't actually be as a competitive to each other. The sharing of the data and interpretation of that is very important. For that interpretation of the data, is very important. I don't know why it comes this way. Okay. The first way of digital technologies provides means to record, store, and transmit machine-readable data. The second wave of digitization, supported by AI and machine intelligence, provides key capabilities for understanding, refining, usage, ultimately monetization of the data. The data, as I mentioned, coming from the text, speech, image, video, sensors can be leveraged to support Industry 4 characteristics. So the concepts of the using of machine learning and AI, and especially the use of sensor data information fusion concept, is an important issue that I will try in this talk to highlight this sort of technology that we need. As I mentioned, in the industry, on the left side of this slides, our country, many countries in the world are involved with this. But on the industry 4 on the right, which has been initiated in 2013 from Germany, and in the Europe it has been accepted, and then worldwide in the North America, in the East, in Japan, China, they have used. So it has been actually extended to very distributed to the concepts called such as distributed intelligence of control. Now intelligence has come to the front end of the technology, to the place that the sensors and the actuators are involved. Usually we use the intelligence in the host computer on the top on that automation pyramid. Nowadays we see that intelligence has gone and moved towards the physical layer. So this distributed intelligence and control is very important. As I mentioned, IoT, or in North America, they call industrial IoT, and the cloud technology of automate complex actually tasks across machine and factories are an important issue in Industry 4. We were talking about the horizontal integration, connectivity across the supply chains and other important. Just in time, flexible, and just in time is an important issue in the manufacturing. As I told you, we are using more sensors and more information. So this concept of sensor and data fusion have been highlighted. And then access to data for better decision and remote access to factory and machine. These are the issues that, again, I just highlight regarding of Industry 4. I have to mention and I have to confess that technology is growing fastly and fastly. And you would see Industry 5 has come to the literature, and it will enhance both machine and human roles. So the concepts of the human in a loop has come ahead, and you would see in the manufacturing industry, we are taking the mechanical opening to create the site to the biological. Biological inspired is an important issue that in Industry 5 will be enhanced and will be highlighted. Nowadays, you see many people, many young people. Even I was very happy, Bahman mentioned 2 weeks ago about the developing different apps in the virtual reality and augmented reality. And you would see Industry 6 addresses this and say that we never interface with any machine in Industry 6, person or drafting table or setup. Instead, it's all done in an application. It's a dream that the human being would like to have this. We take a picture of a rough sketch and click, make it. This is the future prospects of the industry. And if we will be delay, actually we have a delay in developing of Industry 4, what we should do, what will we do with this actually magnificent growth in the future, very near future. Here, I'm very happy to mention regarding of 2 great editors, Gonzalez and Abidi. These 2 are very good persons. They have a good book. Even from 1992, I have put this text in some part of my actually lectures at the university. So in their book called Data Fusion and Robotics and Machine Intelligence, they have a good definition of the data fusion. Data fusion deals with the synergistic combination of information made available by various knowledge sources. Here it has mentioned the sources such as sensors. So it means that information gathered in the search engines is another actually sources. To what? In order to provide a better understanding of a given SEN. This SEN might be financial issue. This SEN might be autonomous driving. This SEN might be gas refinery, power plant, and so on. We have 3 levels of the actually concepts of data fusion. In this part, we call data fusion because we are involved with just some correlated data or the sensors that just gives you a binary value, data fusion. But however, if you could have a feature from the different sources, subsensors J1 and J2 and subsensors K1 and K2, they have the data. And then from this data, we do the feature extraction. If you remember, we had data, feature, and decision on that model that I showed you. And on the right side, we had the information, knowledge, and wisdom. However, in the data fusion, we have 3 levels of data, feature, and decision. It's very interesting on the decision. When we are making the fuse data, fuse decision, we may also consider decision from other systems. It was J and K here, now is L and N, or other information library from web, whatever it is. This is the fuse decision. Just as pass through that because it's the concept of artificial intelligence. I believe that Dariush will leave the PowerPoint for you later on, as well as the recorded film, the video. However, it is again considering the importance of the artificial intelligence. It's very interesting, this one. You see the inference level, inference engine level, we call it. In the ordinary, actually, way, when you have just getting the hard data, you have the simple signal processing techniques that most of the engineers are actually educated with this, and they know that. But if we go ahead, if we consider the identity or attributes or the location of the entity, then we have different estimation techniques: Bayesian nets, maximum and posterior probability, Kalman filter, Bayesian, evidential reasoning. If we go ahead, behavioral and relation of the entities, then maybe we consider some decision level techniques such as neural nets, clustering algorithm, fuzzy logic. And situation awareness or situation assessment and threat analysis are very important issue. They call it in the level 4 or 5 times, sometimes they call it, or the JDL model, Joint Department of Laboratory of Research. In 1970s, we had a JDL model that I just addressed that, and the data fusion is very important issue. This situation assessment and threat analysis. On these two last actually types of data gathering or getting the information, we have to use these techniques, such as expert systems, case-based reasoning, or genetic algorithms, or other algorithms, intelligent algorithms similar to this. So these are some of the applicable techniques for the consideration of the different types of inference. Data fusion, basically, their methods have been divided into 2 divisions, conventional and intelligent one. In the conventional one, we have the OWA that Professor Ronald Yager initiated that in 1983 from New York Machine Intelligence. It's very interesting that it is not just a very simple averaging method. It is ordered weighted averaging method. I give you an example. Say, for example, you would like to know the temperature in a furnace. If you have the thermistor, if you have thermocouple, if you have RTD, an expert engineer will give a confidence level or will give a weight to the thermistor. Thermistor is based on the semiconductor. And then the thermocouple is the second choice for that engineer. And resistant temperature devices, RTD, the third option. So it will give the weight. If we say it gives 70% to the thermistor, 20 or 25% to thermocouples, and 5 or 10% to the RTD, then we can have a good fuse data based on the ordered weighted averaging method. Kalman filter, extended one, particle filtering, all this stuff also tries to estimate the state of the system and tries to make this actually quite close to the real measurement. So it has dynamic of the measurement as well as dynamic of the systems, and tries with the Kalman gain, try to convergence, to make a convergence between what we estimate and what is real in the world. Bayesian method, I have to just mention, in the Bayesian method, we have 2 domains of attraction: domain of correct decision-making and domain of wrong decision-making. And then we have the Dempster-Shafer method. Dempster-Shafer is the generalized of the Bayesian. Dempster and his student Shafer, in 1960s, when Professor Zadeh, late Professor Zadeh also was talking about the fuzzy logic and inexact mathematics, Dempster and Shafer were from the stochastic mathematics point of view. They have mentioned that the human being decision is based on 3 domains, not based on Bayesian one, which was the wrong decision-making and correct decision-making. No, it has wrong decision-making, correct decision-making, and undecided turn. Say, for example, a fighter is just flying. All of a sudden, the fighter will detect another fighter. So this is called friend, foe, enemy. It is my friend. If it is friend, I join to that flight with you. If it is enemy, I have to be ready. If it is some sort of foe, sometimes they call it neutral. It's better to use the word neutral. If it is neutral, it means undecided. That fighter could escape from that area just for the sake of his life or her life. So it is the objective of the human being to actually develop and produce a machine based on human being behavior. So Dempsey-Schaeffer just emphasized on that method. Dempsey-Schaeffer, this is called evidential theory, by the way. Dempsey-Schaeffer method. So it is generalized of the Bayesian. These are the conventional based on the probabilistic and the statistical method, but we have some neural networks, even recently CNN, deep learning. These are the methods that are used in the data fusion. And fuzzy integral operator, fuzzy logic, what they call FIO. Fuzzy integral operators, which is actually divided into two categories, Sugino for nonlinear and Chukwu for the linear part, is used for as one of the most powerful aggregator operator, by the way. So it is used in the data fusion, and usually it's good. We have a comparative studies between this one, fuzzy logic one, and the Dempsey-Schaeffer one, because both of them are claiming that they are trying to reduce the uncertainty. So I ask my students usually to have the comparative of this conventional one with this intelligent one regarding of the producing a robust system. It means less uncertainty involved in the system. This is another issue regarding of that ordered WA or ordered weighted averaging approach, OWA approach. And regarding of fuzzy integral operator, I mentioned Sugino and Chukwu. And regarding our consideration with the elementary or pre-elementary methods or operators for engineer, mean, medium, max, or these are the operators that gives just as a rule of thumbs, it gives good estimates. But if you want to be more accurate, we have used it OWA, and OWA is just involved with two consideration of two fuzzy integral operator. In some cases, it goes to the Chukwu integral one, and in other cases, it is towards the Sugino one. And arithmetic mean is just ordinary weighted one, but the ordered weighted averaging is very effective aggregating method. If I will have a time, we would see here, I just mentioned about the different models. As I mentioned, JDL model is very important, but I just go through that very fast. This is called the multi-sensor data integration. We have different sensors of the data. We use the data processing. First of all, this is the raw data. And then we assign these methods of the Bayesian or Dempsey-Schaeffer. So some sort of actually consideration of this output comes here. But at the end of the story, we are selecting some of these actually outputs, not all of them. Those which are the dominants will be considered on the sensor data selection and then the fuse data. This is a method that has been used and it has given an efficient solution. The other one is 3 levels of the getting the signals, getting the evidence, getting the dynamics. It means data, feature, and decision. So it will produce a database. This Tomopoulos model has been shown. Yeah, sorry for, yes. I had another slide somewhere that just shows the data, feature, and decision based on this model, by the way. But however, here, I just ignored that. Here is a distributed or decentralized signal. Many people are against this one because they say when they distributed, in spite of we have the local decision and there might be a problem on one of them, still we have to consider the some sort of tolerance in the decision making. And many people are against this In spite of it is very good, I think, because it gives a good modularity to the system. So we can consider that, and we can consider the tolerance in the system. However, many people, especially in the military application, they would like to have a center, command and control center. And you know, it has some sort of evolutionary method. I mean, it was C2, first of all, command and control. And then in 1970s, it became command and control and computer, C3, they called it. And then they developed to C4, command, control, computer, and communication. You know, nowadays communication has gotten important issues in engineering design. And then after C4, we have the C4I, command, control, computer, communications, and intelligence, C4I, and making a decision. However, many people are against this, and some people are pro that, they accept. This is the JDL model, as I told you. From real world, we have different sources and data, so we want to make a decision. Here is the human being would like to have the interaction with the systems. There are different levels. Level 0 means pre-processing, level 1, object refinement, level 2, which is situation refinement or situation assessment, or some people call situation awareness. And in the level 3, the threat analysis or threat refinement. And you would see here we have the process refinement. And then in the database management, we have the concepts of the fusion, all these stuffs. And in the level 5 is the interaction between human being and all these sources. In other words, if we consider all these subsystems, I mean, level 0, that was pre-processing and object assessment. Here we have just the signals and individual objects, by the way. But in the level 2 and 3, we have the situation assessment or situation refinement and threat analysis. Threat analysis is called impact here, impact assessment. Here we have the concept of some sort of aggregation and fusion. So we would see that we can understand where we are, and then we understand and make our plan here in this step. No action is done until here that we have the process refinement, level 4. Here, after this planning, we have the control and we have the action. Professor Alan Sternberg, as actually consulting in military defense institutes, as well as a professor at the different universities here from Utah, he has actually mentioned about this, and in many conferences I see him, and it has even in this slides again, Alan Sternberg here, it has mentioned about the very, very interesting things. Could you see here? Electro-optical and infrared sensors, satellite, radar, ELINT, all the electronic data, they are fusing the data, they're returning back for the enrichment of the data. But it's very interesting. The humanity, signal of the commander, signal of the human beings have more effectiveness in the higher level, not in the higher levels. So we would see, sometimes we would see in the war sense, everything is clear, we can go ahead, but all of a sudden, a general commander just stops the people of the forwarding ahead because he understood the trick of the enemy, say, for example. So it's very interesting. Some people call intelligence of intelligence. All the sensors are nowadays very smart, but intelligence of intelligence is another important issue. Here we'll talk about the fusion of the soft to the hard data. It has been mentioned, you see, at the end of the century in 1999, but however, these 2 decades or so, there are plenty of the research work on that I will try with my limited time to go through that. Okay, it's better now we go to the objective of our data talk. I talked about the Industry 4. I talked about the concept of data fusion. Nowadays, we go to see what are they. Okay. Historically, data fusion has focused on processing of hard or physical sensor data, while soft or human observed data has been neglected within fusion process. This is another issue, concept that we see in 2012 also, it has been highlighted again. A soft sensor is an important issue in the literature of the engineering. A soft sensor is an inferential model developed from process knowledge and observations. Soft sensors are widely used to estimate process variables that are difficult to measure online. Really, if you go to an atomic power plant or some places that is very difficult for the people to measure the quantities, over there, you can measure the values through the soft sensors. I mean, with the other hard sensor that you have, you can not explicitly, implicitly, through some formulation, you can find that quantity that you are looking for. So sometimes it's very difficult online to have the hard measurement or understanding or estimating the process variable. But the soft sensor can play an important role in this issue. This example I just mentioned, because in Gonzalez and ABD, it has mentioned that. Then I asked one of my students that I named at the end of this talk on acknowledgement. He did it for me. I just wanted to mention that in our ordinary and normal daily activities, we are involving with the data fusion process. Say, for example, eating. So in the eating process, with your eyes, with your nose as a stiffness, sniffer measurement, and even you might have a bit probe here using probe and just taste it, you are ready to go ahead for your eating, by the way. So 3 rational signals say to you, use your actuators, your hand, and go ahead for eating. But oops, suddenly something happens. Maybe this meal is poisoned. Or, as Gonzalez and Abidi mentioned, I am fasting. So you stop it. What happened? All the sensors and rational signals just motivated you to go ahead. But another qualitative signal or emotional signal just stopped you eating the meal. So fusion of emotional and rational signals, or in another word, fusion of qualitative and quantitative variables, or in another word, fusion of the soft and hard data are involved in our daily activities. Perhaps this is a good example that soft information for human being, what are they? Human-centric fusion, which as I told you, for command and control is used. Human instructions. You can give instruction to the robots as a soft sense. Human in the loop, human hints, human input, human demonstration, human generated data. These are the soft information. For the social and humanoid robot, when you are involving with the HRI, human robot interaction, this robot can serve for you. Even for chasing a mission, when you want to have a rescue team, you are using sometimes the robot. So you have to mention what environment it is and what would be the actually strategy for rescuing of the people. So HRI is an important issue that one of my students is working on, that how we be interacting with it and what we need, what we expect from them. Here is just pouring the water in the glass, or eating, all this stuff could be as an assistant. Here is a good example for the hard and soft fusion. Can you see here? Is a network of the sensors. Is the ad hoc observers. It means here the human, the knowledge here, elicitation. Or as I told you, information library or internet or the web as open source. All these data are coming and fusion will happen exactly to that JDL model, situation awareness and then threat analysis. Is a good example that here you see in 2008, there was a conference on the information fusion, and this has been shown as a framework for dynamic soft and hard data fusion. This is another one using the soft data excluded and soft data included, and getting some sort of the data in this one regarding of the manipulation of the robot in a tracking in a system. So I have given from Mr. Khaleghi from Waterloo University, he has given a good expression in his paper here. I have to mention how we can implement the soft sensor, how we can implement the human signals. The concept of NLP, natural language processing, has an important role here. You see the soft input messages comes through this NLP, and then the hard sensors, whatever they are coming. And then we have the data feature and decision one here. So this is the one that has been addressed here. The soft sensor is based on the model-based sometimes, and sometimes it's based on the data-driven one. If it is on the model-based, we have plenty of methods called Kalman filter, UKF, EKF, or particle filtering. But if it is the data-driven, we have the different sources from data. If it is a noise-free data, we can have the different filters, such as mean filter here, or that one that I mentioned about the OWA one, ordered weighted averaging approach. So these are the methods that has been addressed in the literature. But this soft sensor should be validated, by the way. So we use the historical data. We take the outlier detection. If this is false alarm, no problem. But if it is outlier, we have to detect that and filter it. And then we develop a model and estimate that. And then validation of that is very important. This is for the identification of the procedure for the soft sensor. So again, I just emphasize the soft sensor is for backup of the measuring devices, is reducing the measuring hardware requirement. This is a real-time estimation for monitoring and control. And the concept of sensor validation and fault detection and darknesses are an important issue that also mentioned in this paper. And now we have the systematic approach for soft sensor development. We have the principal component regression and using the partial least square PLC. There are some mathematical methods here that show the systematic approach for data-driven soft sensor using the robust statistical techniques. It is very interesting for implementation. Look here, we have the soft sensors, S1 to SR. So we consider some belief masses. Belief masses means possibility of an action which might be expected to be occurred. It's not a probabilistic, it's just a belief. So a set of proposition will be considered to this, and then we have a special weights according to that. So we have the estimated value of all these soft sensors, and then we have the probability of the hard sensors. So we have the fusion of the probabilities at the end of the story, we make the final result. This is also This is very interesting for those persons who are interested in the multi-agent systems. For example, here you have the soft data agent, you have the hard data agent. From the sensors, the actuators, you have the hard data agents. From the software, you have the soft data agent. So it's a concept of eight agents that develop to handle the different tasks of the system. You know, for these agents, we have to have the filtering, we have to have the search engine, we have to have the search agent, by the way, we have to have the dispatch agent. All of them are located in a multi-agent systems. So in this one, we have the hard and soft, and then fusing all together to data fusion agent. Another method in the NLP is towards using this graphic method, by the way. So with the causality, or what would be the issue or the root of something, we may actually understand and could interpret the information as a soft signal. If I give you this picture, you would see it as we see the portrait of the Mona Lisa here. So when you see the Mona Lisa, you will think about the painter of that, so Da Vinci here. When you are thinking about it, you are thinking where it is located. In the Paris is located, in the Louvre, in the museum. Then you go toward the cities. All of them, it makes a graph neural networks. So in the NLP, we may take these values, and then with this expression, we may actually get a feature, and based on this feature, we make our decision. So these are the methods usually used in the literature. And the concepts of the CNN also is used as a classification of the nodes. We will try that all this information will be collected to a specific, with a less number of the nodes, by the way. So these are the approaches, and actually I think the summary of that is just mentioned in this table. And regarding of when we have different values and different vectors, we have used the principal component analysis to have the independent vector. And then based on that, we can get the data and use it. We just mentioned about that. We have different modality. Say, for example, if we are using the MRI, PET, or something for diagnosis of the tumor in a brain. This is some sort of that. Say, for example, if you have some surgeon, for example, in the system, so you have the human return report from that patient, human report from other surgeon or medication, general practitioner, by the way. Some sort of auto-reporting we have, chatbot could be used here. Some of the heart sensor, blood saturation, and all the sensors that we are using for the heart bit rate recording, for example, ECG signals, whatever we have, EEG, whatever. So the heart sensors with these reports would come, and then we will have some sort of fusion in this respect. This is one of the issues based on the substance. This is for driving. You have a IMU, inertial measurement unit, which has the compass, which has the accelerator. And with this measurement, inertial navigation systems, as you see for feature fusion, we have some part of the soft and we have some part of the hard. And then using the long, short terminology model for this, the LSTM as some sort of neural network, simple neural networks model, then we can consider the position where we are. So this is another issue using the driving. Some applications here, I just summarize it because it's in the military, medical, autonomous driving, surveillance systems, and human-computer interaction. Two of these I just highlighted, one in the autonomous driving and one on the medical one. This is my laboratory at the University of Tehran that we have some industrial automation one. We have use the data fusion on the IT. We have considered big data such as bioinformatics and also in intelligent transportation system. We have used different data fusion methods. So for the autonomous driving, I just go very fast. There are many data sets, very famous ones, such as Honda Research Institute driving data, or the second strategic highway research program in United States. These are the data sets or database that they are considering the behavior of the drivers. And we have used that, say, for example, if you see different consideration of the driving for different people, for example. Here, the goal was this, that the driver should be aware that wants to left turn, to do the left turn. Or here, he has to consider the crossing pedestrian, because collision avoidance is an important issue here. Pedestrian detection is an important issue. Here, regarding of the stop due to congestion, or the U-turn here. So for this, it has been considered with the different people's different, how they act to this. 137 sessions have been used to represent the modeling of the behavior of the drivers. So you would see this could be considered as the sub-sensor for the developing of autonomous driving. Different people with different age, all this stuff. When you are using the driving, autonomous driving, you have to mention in which age you are, what gender you are, or then it's considering whatever has been actually extract from the data through this practice. So this is the data acquisition systems for all this stuff, as I mentioned. And then one of my PhD students who graduated in May 2020, Puya Mehrania from University of Waterloo, still is working with me in his postdoc. And Professor Osman Basir and me were supervising him. It was the topic of his PhD was accident prevention and crash prevention using the fusion of the behavioral and the heart sensor. So you would see here, if we could have the accident reporting and the accident data collection and the management and reporting and data analysis, the use of IoT would be great for a police to have the report remotely. They can consider what was the cause of the accident. If they had the onboard OBD, onboard device on all of these cars, they could give the data regarding of harsh braking, the behavior of the driver, all are considered in this report. As I mentioned, if we ignore the behavior of the human being as one of the factors, important factors in decision making, we will fail to make a proper decision. So this is as an important issue in the crash prevention. We have three elements. You see, human factors. This is very important. Environment. What is the situation of the weather or the road, and vehicle itself. Braking system, steering. What was the cause of the accident? So there are three elements. Here I am mentioning that we have to examine the three main sources of the contribution factors. And we have done a test with the one driving, expert 1, expert 2, and expert 3. We have got the knowledge base, and we have made a database and the rule base according to this method, which is based on the Dempsey-Schaeffer theory. These are the formula of the belief. We have a concept of belief and plausibility. What we call belief is the low probability. What we call for plausibility is the high probability. So with the belief is the correct decision making. With the plausibility, we add up that uncertainty on the systems. And after plausibility, we have disbelief. So we have three categories in the Dempsey-Schaeffer theory. Belief 1 is the low probability. Plausibility is the high probability. And after that is a disbelief. As a matter of fact, we want to have the belief. We want to have an action. So we have used some sort of fuzzy rules for that and fuzzy integral systems that we have used two methods of fusion, Dempsey-Schaeffer and OWA, and we have done the comparative studies. Two methods of the rules have been considered here, database rules. We are using the conjunctive pooling rules, all are based on the formula of the Dempsey-Schaeffer, and we have used the disjunctive pooling rules. In this one, we have a better and a stronger rule for consideration. The formula has been considered here, and the rule base that we have used. If this happened, then this consideration would be considered. This assumption should be considered. And you will see here, again, we are just showing the rules that has come from the different experts. And with these rules, with this method that we have for decision making, all these are coming to that Dempsey-Schaeffer theory method, and then the final decision will be made. I have another PhD student that is in the first stage of that. Is called skill assessment method. Here also we had three databases: the global operation assessment of laparoscopic, the fundamental of laparoscopic surgery, the objective structure assessment of technical. Perhaps 2 weeks ago, I was talking to you, if you remember, that I had a visit from Toronto General Hospital last year, and they're very interested to consider some sort of skill assessment to see whether resident can go ahead to do the operation in the operation room or not, in the OR. So for this case, there is some sort of questionnaire form in the hospitals. They ask from a surgeon to assess actually a preliminary stage of the surgery for a person as a resident. What we do in action, we consider the kinematic data. It means how this resident is doing, how he's using the scissors, how he's using the cutter for actually starting of the cutting the skin of the body. So the positioning, velocity, orientation of that action is very important. With this kinematic data and the video and the questionnaire form at the end of the story, we can make an assessment using the fuzzy measures of fuzzy integral operator. You would see kinematic data and the video from this resident, they come, and the expert surgeon also is just looking to what he is doing or what she is doing at the end of the story can make some sort of skill assessment. Some people say, for example, here, if somebody asks you, what's the probability of the patient has got the phenomena? Nowadays, just experts use the radiology photos or radiographs. What is an important issue is if you could have some expert and could increase the accuracy when just these photos or diagram will be considered with the human experts also. If you would have just human experts alone, there's another issue. It's just sub-sensor. But if you can consider all the image processing and segmentation, all this stuff, then combination of that is another issue that nowadays the combination of the expertness of the people and the hard sensors. I just go mention here just through some of good papers that I have seen, which is the last one. With a few minutes, I will finish my talk. Just addressing some of them in future, you might use that. Is a characterization of hard and soft sources of information, some sort of practical illustration. You would see different cameras have seen the whatever in the nature we are looking for. But we have one analyst, you see, with a 10 years experience. And one just new coming analyst, very new one. They are considering, but you would see with all this data that we have from this person and the expertness of him, and also all the hard data, we have the fusion node here. But decision maker is still considering these subsystems with the expertness of this person with the 10 years experiences. So some sort of fusion of the soft and hard data was coming in this example. There are just generation of the fundamental data set for hard, soft, and information fusion. It is very, very interesting table, by the way. Maybe on that example that I mentioned about the human or the human being signal, you would see for the soft sensor, most of the weights come from the human being himself. But less would be from political climate, from the TV, radio, broadcasting, websites, or from audio, imagery, and video. And you would see vice versa. When you have all the hard data, such as the radar detection, event occurrence, all this stuff, electro-optical, radio frequency, video, all this stuff shows the percentage of the hard and soft. So it was a good diagram to show the effectiveness or the weights that could be associated with the human being here, or with the definitely hard sensors here. It's a good paper. And then some sort of explanation regarding of that. And then again, this model, human source number 1, this data translation extracts the data, normalizing that, ready for going to fuser. Human source number 2 also the same. And then the hard sensors are coming. This is the architecture used for the soft and hard data. This is for reinforcement learning in the data fusion. This is the JDL model. We were talking about the JDL model. This is the end of the situation assessment. After preliminary stage and object refinement, we have the situation assessment, and then this system users are analyzing the threat analysis afterwards. Here, the soft data fusion have been used. This is a model very interesting. It's called the OMBIS model. It has the observation, it has the orientation, decide, and act. But through this signal processing and pattern recognition, we have the soft decision fusion. Hard decision fusion also comes, and then you can control. It's a good model that has been mentioned in this paper. This is the last few slides at the end. It shows in the industry 4. I'm very, very actually happy to show this to you, that you would see if we can implement such this, we can avoid many, many accidents in the power plant or industrial, big industrial complex. You would see if we use the eye tracking for the employee, And if you use some sensors on the skins, on the body sensor networks, and then with the different scenarios, then we can see what is the situation awareness. Here's a mimic panel in the power plant. You see it's a mapped up eye tracking data. Plenty of eye tracking data. But here you would see we have here 1, 2, 3, 4, 5, 6 clustering with 100 participants of the staffs. It shows through the eye tracker, it shows what exactly operators are looking. So in future, if an accident happens in a power plant, we can consider whether the participants in the control room were concentrating on these important parts. Say, for example, in the power plant, it's very important we have the level of the boiler. The top drum boiler level is very important issue. If it exceeds from the level that has been assigned, all of a sudden, these bubbles will go to the turbine and it will damage the turbine. And it may actually also injure the people. So we are considering in the history whether the technicians or the chief engineers were concentrating on the important actually variables or not. So with the eye tracker, we would see the zones that have been highlighted here, and through the predictive maintenance in Industry 4, we can avoid of this. So still we need the good hard sensors, but still we need the behavior or model of the operators, whether they were concentrating on these clustering parts. Say, for example, the vacuum of the condenser is very important. If we cannot have the vacuum in the condenser, the system efficiency will become very low, very low. So at the end of the story, I just mentioned, we went through the hard and soft fusion architecture, and we will see the accuracy of the system will be increased by the use of the hard and also human being command. There are some references here, and all my graduate students and the PUYA who have been graduated had helped me to actually prepare this presentation. Thanks for your attention. Sorry for a bit longer time than was expected. Okay, I will be at your service.
Thank you very much, Dr. Moshiri. If anybody has any questions, you can ask now.
Yes, this is Mahdi. Thank you very much, Dr. Moshiri, for the great presentation. So actually, I have a question about sensor fusion. Sensor fusion and data fusion supposed to be the same terminology or somehow different terminology?
Yes, thanks very much for your question, Mahdi. Yeah, as a matter of fact, when I was studying the sensor data fusion, it goes back to 25 years ago, perhaps. I saw that they use this concept, sensor fusion, data fusion, usually mostly involved with the physical data. But we had a shifting towards from data, as I mentioned, to the information. That's why another concept came, and a very popular journal called Information Fusion also now with a very good impact factor near 13 point something, 13.5. It means that the industry and academic are very interested. It's regarding of information fusion as a general. Yeah, sensor usually we mean what we use in the car, what we use in the industry. The data a bit gives some sort of knowledge for us, but still there is a lot of ambiguity on that. But when we go hierarchy a bit higher, we would see information. From information, you can discover the knowledge. But from the data or sensor, you can extract the feature. Say, for example, the distance between our car and the next car. This is some sort of rangefinder or the distance detection. This is called actually sensor and data. But if we go and use information fusion, I had a good research work with one of my PhD students. He has used the multiple engine search engines for considering some n-grams of keywords. Say, for example, you put some keywords in the Google, but the Google give you a one hybrid priority list. But if you add other search engines, such as InfoSeek, AltaVista, Yahoo, Microsoft Network, many, we have a lot, Bing, they have different index for priority, but at the end of the story, if you could fuse them, you could give a very good priority list. So on that concept also, the word data and information is used. So we have to consider two big categories. I believe there are some ambiguity between them, but still you have to consider the hardware and software.
Thank you very much.
You are quite welcome. Sorry. Yes, I will be at your service. I wanted to talk about that twin digital. That twin digital is very important. How we can model the physical systems and digitize that, but considering the human being. The last slides which I showed, I was very astonished when I saw that paper. You saw that with eye tracking, we can simultaneously consider the hard and soft issues regarding of an accident if it happens, or even making an accurate decision.
I have a question, Dr. Moshiri.
Sure, Amir.
In one of the research projects in our company, we were trying to use a digital twin to have an estimation of the defaults on a pipeline system. We were trying to get to a point that we can have a digital twin of the pipeline systems together with the engines and the things that the parameters that are creating vibrations on the pipelines. And we were using it for smart maintenance to predict the defaults and defects on the lines with their intensity and everything like that. And we're using AI for it. Now, the problem that we were facing was that the digital twin was created with simulation systems, simulation software, and it was giving us an ideal situation simulation and the defected system version of simulation, and we could use it to train our artificial neural network and use it inside our genetic algorithm that we had for it. However, the reason that we were using the digital twin created in a simulation system was that we didn't have enough data of the real world defected pipelines to train our system with. And with this digital twin, we could have all kinds of like data combinations, and we could train our software with it. And it was good. We got a accuracy level of 96%, I guess, which was quite acceptable. However, in the real, if we want to use this in a real industrial environment, the results from digital twin could not directly be trusted because it was the system was trained inside a computer bubble rather than a real environment. However, we could have some real case data to calibrate our system, calibrate our digital twin to better represent the real environment. I want to know if you are aware of such combinations and combining the real industrial environment data with the computer simulation to create a calibrated digital twin.
You are right, very good. I had very short experience on this respect. I had a student working on the pipeline management regarding the leakage detection. By the way. So the leakage detection, because we have a lot of parts of actually gas getting out of the pipes due to problem in the composite materials of the pipes, and also the fittings are very important. So usually they say sometimes near 25 or 30% of the gases through the pipe has been actually just spared in the earth. What we have done also, OGLA is a software that is used for the pipeline management. But some portable ultrasound flow meter can be used in the system, even 2 kilometers by 2 kilometers in the top on the hills, in some places. You know, sometimes also a team with the helicopters, they go and they just check because it's not a normal situation. Sometimes it's hazardous. However, getting the information from the real world is very important if we could have all this data. I mean, they are doing the pipeline, they're fitting it, all this stuff, but at the end of the story, we will see that in this specific marketplace, rather than 2 kilometers after that, we will see some part of the leakage of the gases. I think probably for making a more accurate actually calculations for the pipeline management, we have to consider some real on-site detection as well. These online detection systems could be added to that estimation method that you have, such as a traffic control. We should have the estimator with the estimator, just understanding what is the flow or the speed of the cars. But we have to have some local measurement in such as loop detectors, whatever in the intelligent transportation system. But for your purposes, I think that software gives you some sort of confidence level for you, but it still needs some on-site actually detection. And unfortunately, we hadn't enough chance to have our test on the on-site because for the master thesis, just master dissertation.
Yeah,
it was just they just needed some sort of simulation for the purposes. But however, I think we have to collect all this data, and in this collect, we can actually consider a very more accurate. By the way, there is a person, PhD person, working with another professor at the University of Tehran. We are trying to use that, what they call, all of a sudden I forgot it. You call it deep, so inside the pipe, it goes intelligence find pin, sorry, peak.
Okay.
Peak is used for the some sort of a moving body that goes to the pipelines before starting the flashing the gas in the system. It goes and it can see the composite situation of the welding. Is it good? Is it smooth? Is it rough? So the roughness, smoothness, all this can be analyzed before starting of the pipeline. So they use the peak, intelligent peak. So one person has used that with the help of the refineries in some place in the Ministry of Oil. But I know that in Canada, in Calgary, there are plenty of good teams over there that they are fusing the data in this way. Maybe I can find the paper for you, and also the paper that my student has used. It might help regarding of the leakage detection on the pipelines.
That'll be awesome. Thank you very much.
You're welcome. With the use of the extended Kalman filter and UKF and particle filtering, they are using these methods, which are the conventional methods of the data fusion. Please let me know. I just not forget this and give you a couple of these papers probably.
Sure. Thank you very much.
Thanks very much, Amir.
Great.
Thanks very much. So I think, dear Dariush, probably next 2 weeks, your topic would help us to implement some of these ideas.
Yeah. Thank you very much, Dr. Mashiri, for your great presentation. Yes, I am planning to have a short discussion in the next 2 meetings, so on experimental aspects of design and implementation of IoT systems. So hopefully, so with your help and other participants in the next 2 meetings, so we can develop a better design together, and so, or maybe we can implement it in some common or interest areas together. And thank you very much for your presentation. If there's no other questions, no comments, we can wait for the next 2 weeks on June, I think, 20th. Yes, we will have the other meeting. Any other questions?
Maybe for next 2 weeks, I may invite, I invited, but probably she hadn't enough. So one of the persons who initiated a startup accelerator. I told plenty of my friends are interested to set up a startup and working on the new area. They have found some capabilities and they are trying to absorb the money from the governmental sources. And she was very happy to help us. Probably next 2 weeks, I will invite her again. Definitely comes and explain about, after your talk, we see how we can have the synergic collaboration with her. They have invited me as a mentoring for them, but I thought it's a big, good chance that we start working with each other and merging our all capabilities towards developing a good startup activities.
Yeah, and hopefully Amir will help us in developing a better design. He has very good experience in IoT and AI systems. And I wonder, Amir, if you could help us with your advice or on your contribution.
At your service, sir.
Thank you.
I'll be more than happy to.
Thanks very much.
Thank you.
Thanks very much for everybody who attended this session.
Thank you, and have a good day.
Bye-bye.
Bye, everybody. Bye.
Thank you, everyone. Thanks.
Bye.
Bye.
Bye.